It's great to be here, and I think many of you were here for the previous session, and we'll kind of agree that it's super cool to have the action-packed AI for Good afternoon here at the conference. And it's always really, really cool to speak after Jake Poroway, the Jake Poroway, the man who started it all. So it's a tough act to follow, and I'll do my best. So anyhow, my name is Mojsilovic, and I lead the AI Foundations department in IBM Research, and I also serve as a co-director for our Science for Social Good program. So in a way, today I'm going to be wearing both of my hats, my AI hat and my social good hat. And I am going to, of course, be talking about the world of opportunities to do good with data, with machine learning, and with AI. And I hope it's going to be a good part 2 dose of inspiration for all of you who are kind of interested in this space. But I'm kind of also hoping to leave you a little bit with some questions, and especially the question, are we doing enough, and what are the kinds of things that we need to be doing more or better in this space. So let's get going. I'm going to go back like a couple of years ago when I was leading our data science team in IBM Research, and it was the time of data science craze. You'll probably remember it all. And it reminds me a little bit of AI thing today. It's kind of similar. Of course, data scientists back then were the hottest skill in the world. They were commanding huge salaries. Data science was transforming our lives and our world, and it was changing industries and all that kind of stuff, a little bit of deja vu. But anyhow, data science was doing great. But actually, I think that a lot of data scientists were kind of feeling that itch, that feeling that we kind of had this really valuable skill, the sexiest skill on the planet. And it kind of seemed right to use it for things that would go a little bit beyond just, industry and consumer problems. So many of you will remember this quote. It's all over the place now. Anyhow, so we were feeling that kind of what am I going to do? Can I help the planet? Can I do some good stuff? And we tried the usual things, right? We went for hackathons. We tried to do some volunteering. Back then, there were not so many opportunities. But even that didn't feel quite right because, it was a little bit odd that we would be working on problems that matter, on big challenges of this planet in our own spare time. Like you go and you give an hour or 2 here and there. It was kind of a little bit weird. So we kind of started to think about it, and the thought process was the following, like, okay, so we work for IBM, which is like one of the technology giants, and especially we work for IBM Research. IBM Research has about, I don't know if you know that, more than 3,000 people around the world and in about 13 labs around the world. So it had to be a way to actually tap into this talent and do good a little bit more formally. And we were trying a bunch of stuff. We did not know exactly what we want to do, but we knew we want to do something. And then an interesting thing happened. In 2014, there was the outbreak of Ebola epidemic. And we kind of thought, okay, here it is. This is our chance. This is our chance to do good. Of course, we're data scientists. We have this cool skill. We're going to go and mobilize the community and get the volunteers and connect with all the other data scientists, and we're going to help out. And now, in retrospect, it was a kind of a little bit too bold. And we, of course, did the usual thing. We organized hackathons, and we organized brainstorming sessions and data dives, and people were showing up, and they were saying, oh, I'm a data scientist. What do you want me to do? How can I help? We didn't really know what we could do, so we tried many things. Data was not there, so we started to collect the data, and we tried to collect data on hospitals and Ebola treatment centers and a whole bunch of other things. Of course, we had food, and we had great time. So as I look back,
Obviously, we didn't do much in case of Ebola, but it was actually an incredibly valuable lesson. And we learned two really important things in this attempt to help the world. The first thing is that, we are not going to solve the big problems of this world in hackathons. Don't get me wrong, I like hackathons, but they are not exactly the best vehicle to get stuff done. They're really good to build your network or learn some new stuff or do some PR if you have a new product. But saving the planet, not so much. The other thing that was actually really painfully obvious in this experience, and probably in many others that we had, is that we actually don't know anything about the problems of this world. Like an average person like you and me, we don't know what it means to be poor. We don't know what it means to be hungry. We don't know how diseases happen and why and where. And we don't know how it feels to be discriminated against. And then, quite frankly, how do you solve a problem that you do not understand? So next time we did things a little bit differently. In 2015, we started a program called IBM Science for Social Good. And in this program, we actually team with NGOs, with public sector agencies, with social enterprises, with folks, organizations who are actually on the forefront of these important issues. And we talk to them and we team up with them and we actually try to learn about what they're experiencing. We try to learn about the problems that they're working and figure out if there is a space for technology to help. And if so, can we do it together? Can we scope a project? And then we invite our scientists and researchers and engineers to join these projects. And most importantly, we award fellowships to undergraduate, graduate, and postgraduate students to come to our lab and actually work with us together. So I'm going to show you some examples of how it works and what's really possible, because I think it's really a nice illustration of the world opportunities. And then we can talk some more about some other stuff. So interestingly enough, the very first project that we did in this program was tied to another epidemic. It was Zika. And we teamed up with the Carey Institute for Ecosystem Studies in Millwood, New York, to learn more about infectious diseases and global epidemics, because it's actually an increasingly important problem. We are seeing more and more outbreaks of unknown diseases or unexpected outbreaks. And interestingly enough, even though we are getting much better at how we handle these epidemics or new diseases, our approach to combating them is actually very reactive, right? You're waiting for an epidemic to happen, it happens, and then you go and do something about it. But wouldn't it be actually really, really cool if we can be one step ahead of the disease and figure out when it's going to happen or where or why, and then do something about it before there are actually so many casualties or fatalities. And one thing that we actually learned from the folks at the Carey Institute, I didn't know that before, is that the majority of modern diseases are actually of the animal origin, like chikungunya, Ebola, West Nile virus, Zika. These are all viruses that reside in animal. The animal doesn't get sick because they have natural immunity, and then somehow, using some very weird transmission mechanism, let's say a mosquito bites an animal, then mosquito bites a human, that virus gets transmitted to a human race. One interesting thing with Zika is, even though we actually understand this mechanism really well, we actually do not really know which animals are reservoirs of Zika. We know it for actually very few animals in Africa, but not for other animals around this world. So in this project, we actually teamed up with Carey to figure out if we can use the data that's been collected about different animals, data such as behavioral, physiological, social data, like the body size, the body mass, the number of offspring, that kind of stuff. And can we use it together with known information about the reservoirs of other zoonotic diseases to be able to predict what are the animals that are most likely to be Zika reservoirs in another part of the world. And this is actually very interesting and important because testing an animal for a virus is a very costly endeavor. So being able to do this really allows us to cut the cost of this expensive field testing, but it also allows us to do much more targeted, animal protection or mosquito spraying, and even just kind of predicting or plotting the risk maps of the disease. Another example, last year we teamed up with an NGO called Neighborhood Trust to understand if AI technologies can help us in address poverty or prevent low-income individuals from getting into the cycle of poverty. I'm not sure if you're aware of that, but like 3/4 of Americans live paycheck to paycheck, so barely making their ends meet. And what happens, oftentimes you get an unexpected hit or unexpected expense, such as your child goes to a hospital or ER, or you get a parking ticket, and then you need to borrow money and you go down that spiral of predatory lending. And Neighborhood Trust is actually provides financial services and financial counseling to low-income individuals and low-income communities. And basically, they're counseling them how to manage their money, how to stay out of the debt, and even potentially save for the future. But what's really a challenge for them in order to do so, every year they work with about 6,000 individuals. And in order to do so, they employ a small army of financial advisors. So you can see the problem. If you want to scale this model, and if you want to grow, and if you want to touch more people, you need to get more financial advisors, which is actually a very costly and constrained resource. So in this project, we actually teamed up with the Neighborhood Trust to see if we can use their data and all the experience that they accumulated over the years to train AI models and machine learning models to actually provide a financial counseling or to predict financial position of an individual or provide a financial strategy or advice that is actually targeted to their unique position in life. Another example, a completely different field, is the recent work that we did with the United Nations Development Program around automatically tracking the progress against sustainable development goals. You probably know about the SDGs. It's in 2015, most of the countries of the world adopted this sustainable development agenda, which is like the commitment to make this world a better place in so many levels and in so many areas by 2030. And this agenda is really articulated with 17 sustainable development goals, like no poverty, no hunger, life on land, climate, and these goals are really nicely encapsulated with 169 targets. So, for example, one example is to say by 2030 we will reduce maternal mortality below 0.07%. And most of the nations in this world, most of the countries in this world are really very actively trying to articulate these goals and the actions that they are going to do against these goals, and they're putting them in their national development plans. So UNDP is working with the government and government representatives to shape this strategy and then to track the actual progress against these goals. Now, the challenge with all of this is, in order to track the progress, UNDP really actually needs to manually read these national government plans. So you have to go there and paragraph by paragraph see which paragraph maps to a particular SDG and a particular goal, and see if there is a progress. And you can see where I'm going with this. So in this project, we actually used natural language processing and machine learning to actually try to map very specific sentences and paragraphs in national plans and map them to the corresponding SDGs and goals. And we were able to actually create a tool for UNDP that really automates this tracking process. So these are just a couple of examples from the work that we've been doing this for 3 years now. We executed over 25 projects, and it's been a really incredible journey. I think when we started this, we didn't expect this to be so telling and so rich. We've done things from monitoring and modeling hate speech to using causal models to actually come up with policy guidance for different things around the world, to using generative models to create new materials and new antibiotics of last resort for fighting antimicrobial resistance, all the way to actually identifying humanitarian crises around the world in real time. Now, oftentimes, actually most of the time when we show this project map, one of the first questions that people ask us, well, oh gee, okay, but how do you actually decide what you're going to do? How do you decide which projects you are going to run? And it's actually a very interesting question. It's a little bit of art, and it's a little bit of science, and it's a little bit of our desires to do good. Sometimes it starts with available data. Sometimes there are agencies and organizations that actually reach out to us and ask questions. But actually there is also a little bit of a process to it because we've gotten better and smarter over the years. So you can see kind of like a formal representation of a life cycle of a social good projects on this slide. And of course, it always starts with this big idea or a desire to do something special. Say, okay, we want to do something about opioid crisis, or we want to do something about human trafficking, or we want to do something about hate speech. That's just a big idea. Then the really next very important step is this step that we call ask, listen, and learn. So whenever we have an idea and whenever we have a topic, we actually reach out to people who are doing the work in this space, whether it's an NGO, whether it's an agency, whether it's an organization, and we actually listen to them. We ask them to tell us more about this field, and we ask questions, and we talk for hours, and it's kind of you're really learning the mechanics of the problem. It's almost like going back to school. What I think is the most important part is this part 3, which we call the map and iterate, is once you kind of understood the question and the problem and you kind of know what's going on, you need to figure out, can you map it back to a technology? Is that something where technology can actually help? So that is where we actually work together. We talk about things. We teach our partners a little bit about technology because they don't quite understand it all the time. We ask them, okay, do you think that this kind of thing can help you here or not? And this is actually a place where most of the ideas die. No matter how excited we get about it, this is a place where you actually discover that maybe it's too early, or maybe there is no data, or maybe your partner is actually a very, very small organization because NGOs are really spread too thin, and maybe they don't even have time to work with us. So this is the place where you actually nail it and map it into the actual technological solution. And when that happens is then, well, it's the usual stuff. You scope your project and you go and execute. And just to go back again, this is actually my favorite part. As much as I like data and as much as I like modeling, and I'm a modeling junkie, this is the part that I enjoy the most because it's almost like, hey, you go back to school and you learn so many new things, and you see these incredible stories with technology, the kinds of stories that you are not even really able to imagine. So I'm going to give you one example. It's the opioid project that we've started last year, and we are actually doing it, moving it forward as a long-term initiative. You know about it. Opioid is a huge crisis, probably one of the largest health crises in the modern American history. I didn't know about it, but more people died from opioid addiction than from gun violence and car accidents combined, and that's kind of scary. What's even more scary with opioid addiction is that most of the time it starts in a really benign way. Like you have a surgery, or you have a pain-related accident or incident, or you go to a doctor and you get that little bottle of pills, and sometimes it's more than what you need, or sometimes you just keep on taking it beyond what's needed, and very soon, a couple of months down the line, you become an addict. And the question is, what can be done to prevent these kind of things? So what can be done is actually to create much better guidelines for opioid prescription, more responsible, more informed, more educated. But the question is, how do you come up with these guidelines? So here is an interesting thing. I mean, maybe purely by accident, maybe just because we happen to own the company in IBM, there is a company called Truven, which is one of the largest aggregators of healthcare insurance data in the United States. Now, the funny thing is, healthcare insurance claim is a weird thing. It's made for a purpose of a provider being reimbursed for their services. But the healthcare insurance claims has a lot of interesting information. It will say, when is it you went to a doctor and why? Because there are procedure codes. So it'll say, hey, this person had a surgery on this particular date and it had a prescription for an oxycodone. And then later on, you might see another claim saying, hey, maybe 2 years down the road, 3 years down the road, this person actually entered into rehab, or this person was prescribed methadone as a way of combating their opioid addiction. So healthcare insurance claims longitudinally tell fantastic stories. So it's really a matter of putting up together a machine learning toolkit, causal modeling toolkit, that can actually help us tease out these kinds of information from the healthcare insurance data and be able to say, okay, what kind of prescribing behaviors are more risky or less risky? What type of prescribing behaviors lead to more addictions? What type of population is more vulnerable or less vulnerable? So this is a project that we started last year. We have some interesting results, but we're actually moving it forward pretty aggressively also together with our partnership with the MIT lab on AI for shared prosperity. Now, another thing that people always ask us when we talk about these projects is, well, okay, so how do you move these things into products, right? After all, it's IBM. Or maybe it's just what you're doing is real philanthropy. And the answer in both questions is no and no. It's not about philanthropy. And no, many of these things don't make it into products. Some of them do, but most of them don't. Because it's really about the fact that this kind of work should be the fabric of how we do business. Not just at IBM, not just at Google, not just at any company, but everywhere. Because it's really about the fact that it's critical that we as a community of AI practitioners really direct this technology towards problems that don't go just towards revenue or profit generation. It's really critical that we shape this technology and use these problems to create new technologies and advanced AI in a way that we won't be able to do if we just focus on very, very narrow and myopic things. And when we do that, I mean, that's some very interesting things happen. First of all, these problems are very hard. They're very difficult. They're very multifaceted. They're very multidisciplinary. So as we try to solve them, we actually get to think outside the box. And then we become better scientists and better researchers and better engineers and better developers, and we actually help our companies make better products. That's where ROI is. Another piece of good news is that doing good with AI is actually good on many different levels. So I'll show you some examples. These are the clips from the most recent press, and you guys know all about it. You know that AI has a talent problem because there are so many companies pouring down the job postings in AI, and they simply cannot find enough skilled people. We also know that an average AI practitioner looks kind of monolithic and not very diverse. That's kind of well known. But I just kind of want to show you a scorecard from our program. As I said, we did 25 projects in the last 3 years. We awarded 29 fellowships. Now, for these 29 slots, we had 1,100 students apply. Sometimes we joke it's kind of more difficult to get into our program than into Harvard, and it's a joke, and it's not about us and it's not about our program, but it really tells volumes about what is it young people want to be working on. Everyone wants to be working on. In the last 3 years, we had 120 of our scientists contribute to these projects. Most of the time, we actually have to tell them no and send some people back home because the projects are simply overstaffed. Because these problems are really the magnet for getting the folks into the field and for keeping them really passionate and motivated and energized. Another thing, if we talk about diversity, 1,100 slots, we had almost equal representation of young men and young women. Another thing that we kind of face in AI today, and it's kind of really silly, we're in the midst of this AI craze, right? But then on the other hand, except for the real hardcore AI practitioners, very few people actually have some decent intelligence about artificial intelligence. Many people think they know what it is, but at the end of the day, it boils out, oh, no, it's not Alexa, and no, it's not Terminator, and it's not going to extinguish human race. I just kind of, preparing for this talk, I did a little Google image search on artificial intelligence, and this is how artificial intelligence looks like. It's cold, it's detached, and it's artificial. But if you're asking me, this is how I would like artificial intelligence to look like, or maybe like this. So these are the kinds of stories that we want to tell. And these are the kinds of stories that we need more because they really demonstrate in the best possible way to the decision makers of this world, to the policy makers of this world, to the CEOs and CIOs of this world, or the general public, what the AI can actually do. But I also want to be realistic, and I also want to admit that AI is actually a new technology. It's really in its infancy. We are not even beginning to do stuff with it, right? And AI has some actual challenges and problems. We know that, AI things can sometimes produce unintended results or can behave in somewhat unexpected ways, right? We also know that algorithms can gulp human biases. And no, AI is not unfair, but we tend to be pretty biased species. So when an algorithm gulps our bias and it codes it up and automates it, then it spreads it around like crazy. AI can be black boxish and opaque and not transparent. It can be hacked and poisoned. So there are lots of things that we need to be thinking about moving forward, because in the past, we used to build models and algorithms and AI solutions for accuracy and performance. It's really phenomenally important that as we move forward, we learn how to build them and wire them and engineer them for trust. And that, in a way, is actually one of the major themes. It was a major theme of our program this year, Trusted AI. So we ran a set of projects that focused on, how do we build more trustworthy AI technologies. Just to give you a couple of examples. We've just completed building one of the most comprehensive algorithmic fairness toolboxes in the marketplace, so hopefully it'll be out soon, and so stay tuned for more on that. We also just released a paper with an idea that basically says, well, you know, maybe AI systems or services or algorithms should come with a user's manual. Like, because when you go and buy a blender or a hair dryer or a car or whatever, it comes with something that's called a user manual. Isn't that kind of logical thing to assume about an AI service that, by the way, someone is going to put within an enterprise workflow to run a system? We had a project around trying to understand why is that deep learning networks see skin tones so differently, especially in facial recognition applications, and is there something we can do about it? We try to see how we can use blockchain to safeguard the results of complex simulations or complex models, especially those that are being shared across multiple parties. We try to build and propose better transfer learning models for applications in microfinance, especially in cases where you don't have enough data, so you are building off of the previous applications. And last but not the least, we also played Pac-Man by teaching AI agent moral values, which is basically, hey, Pac-Man, do not eat the ghost, as a way of demonstrating that, you know, AI can actually learn the values of our societies. So that kind of gives you an idea of what's possible, but I also kind of want to look one step ahead, and Jake touched a little bit on that. I think all of this, everything that you see in the work of IBM research and in the work of all the other great groups in this space, it's still the beginning, because these are some really, really hard problems, and they're going to take years and sometimes decades to solve. So I don't want to sound pretentious here and appear as if, hey, we solved everything. But what's also more important is we're only beginning to scratch the surface, especially in this industry, because our industry is not exactly wired for good. No industries, and I want to go a little bit deeper and talk about it for a couple of minutes, because it requires some thought and requires us to come up with some new ideas. And what do I mean by that? Okay, so let's just take a look and see what does it take to actually create a new product or a new service. And it does not have to be an AI product or an AI service. It can be any. So it can be, hey, I'm IBM and I want to create a new Watson, or I'm a Johnson & Johnson and I want to create a new shampoo, or maybe I'm Mars and I want to create a new chocolate. What does it take? It takes three things. Okay, I need to have some dollars, some actual funding to develop my product. But it's not just the only thing. I also need to have some domain expertise. Presumably, I got to know how to make a chocolate, or I need to know something about artificial intelligence. So I have to have that domain expertise. And I need to have the skills to complete my project. So when you're an IBM or Microsoft or Google, for that matter, when you're Johnson & Johnson, when you're Mars, what happens? All these three things you have in-house. It's all yours. It's actually a very easy thing to do. Now, what does it happen when you actually try to solve world's problems with technology? These three things are all over the place. With funding, it sits somewhere. It's usually in the government, public sector, in private foundations. Well, but hey, the domain expertise is someplace else, because there are NGOs and there are organizations who actually battle these problems, but they don't have that funding all the time. And then what happens is the skills who can actually help us put these things together, well, you know what? They are in IBMs or Microsofts or Googles of the world. They're in startups. They are in academia, but they are not there. So unless we actually learn how to triangulate these things, unless we come up with better business models to do good, we actually won't go very far away as a society or as an industry or as this world. But if we do, and that's my positive note, right? If we do, we have a really, really good shot to come up with technologies that really, truly represent the future of this industry and the future of the world. So that's something kind of to think about. Thank you. I'm good. And I'm good with time. Questions?
So I was wondering, did you get a chance, or is it your group that had any work to do with the Gender Change Project, or looking at how facial recognition APIs from local companies were biased in certain ways?
Yeah, we actually, not my group, but we did it as a part when Gender Shades announced their results. We actually, in a way, we were very fortunate because we were already working on figuring out how to address some of these issues. But we worked very closely with them, and then we essentially did a couple of things: improved the data sets that were trained, that we trained our facial recognition services on. We improved the algorithms, and we were able to kind of do a pretty significant reduction in the error rate between different skin tones and genders.
Can I ask a quick follow-up question? Did that change any of the ways your teams are going about evaluating their processes before releasing them?
It goes back to something that Jake said, and I keep on thinking about it. So when it does change things, because I think it's critically important that the community questions everything that we do. And why? Because in AI, given how early we are, given that it's new technologies, there are going to be things that we did not expect. I remember a time when people trained the first computer vision system to recognize images, and everyone was so excited. I mean, like, gee, isn't this amazing? And no one actually thought about the fact that thing can see different skin tones differently. It was not in the back of people's heads, so no one did it intentionally. But as people bring forward these challenges and shortcomings, I think that's the best way to stress the technologies and to help technology providers actually really make better solutions. So there is a responsibility on technology providers to actually step in and do that, but we do depend on community for that kind of feedback. All right.
Very good. Thank you very much. Thank you.